we will look at the basics of how computers talk in the internet. Then we will have an overview look of this thing called TCP/IP, which is an important prerequisite before we start talking about HTTP. Then we will define HTTP, what this is. And we'll briefly talk about related topics in, let's say, the domain of HTTP. And then before we start to use a tool called Postman, because I want us to do a little tutorial so we can better understand how HTTP works. I will explain something called HTTP methods, and then we will use that tool to, actually get involved with some, internet communication or HTTP communication. So before we begin, I want everyone to download this app. It's called Postman. I'm going to put the link in the chat. So let's all make sure we download this. And while it's downloading, we will go through the content. So let's start with the very basics. Okay, and I know someone asks if getting into HTTP is too much if you don't know how networking works. So that's exactly what we will start with. First, we will talk about the basics of networking. Then we will discuss HTTP, and then we will get into using this tool I just told you about, this Postman application. So let's think of a very simple scenario. Okay, simple scenario. You are sitting in front of your computer like you are now, and you want to visit some website. Let's say the Apple website. In this picture, you would be called the client. Okay, the computer from which you are trying to access the Apple website is called the client. And the computer that is going to give you the landing page of the Apple website is called the host. Okay? Knowing these two terms is going to be important when we are going to get into the, as we get further into the topic. The client is the computer that is requesting something, that wants to see something, a video, a website, and the host computer, that's also a computer, is the computer that's going to send, is the computer that will provide you with that document, with that video. Okay? Now, depending on what you're trying to request from the host, or depending on what you're trying to give to the host, you have to use one of the several protocols that are available. Okay? Now, our focus today, of course, is HTTP, but let's say that you are trying to send an email from your computer to another computer. The protocol you would use would be something like SMTP. That's for sending emails. There's another one called POP3, which is for receiving emails. Then you have something called FTP, which is specifically for transferring files, uploading files. So, however, this relationship is the same. One computer wants something, we call that computer the client. Another computer is going to send, or is going to respond to that request, and we call that the host computer. Okay? Now let me tell you about this thing called TCP/IP, because I want us to focus on this HTTP protocol. And then I will revisit this idea of the client and the host and how computers in a network communicate to each other. So the TCP/IP is formally known as the Internet Protocol Suite. There are two parts to the Internet Protocol Suite. One is the standard, and the other part is the implementation. I'll explain these in a second, but just let's be clear with our definitions. So everyone calls it TCP/IP, but its formal name is Internet Protocol Suite. So, and this is two things: a standard for how a computer should communicate on the internet, and an implementation. That is to say, the software that makes the standard possible. Okay, we don't need to worry, we don't need to know these technical details, but I'm just establishing these definitions because it will help us. And the Internet Protocol Suite, or TCP/IP, manages the communication on the internet by doing 5 things, by facilitating 5 things: packetting, addressing, transmitting, routing, receiving. I will explain these 5 items very shortly, but understanding these, the 5 properties of the TCP/IP model, or the Internet Protocol Suite, will help us, appreciate the layers of this model, which are the following. I will very shortly explain to you. I will go back to the previous slide where we had the client and the host, and I will explain how this TCP/IP model fits that picture. There are 4 layers to the TCP/IP model. Application layer, that is where the HTTP protocol exists. The transport layer, that's where we find TCP, the thing I just talked about. IP is in the internet layer, so we have TCP/IP. TCP is the transport layer, IP is the internet layer, and then finally we have the link layer. So the application layer, as the name suggests, refers to, well, applications that either run on your computer or run in the browser. Okay? So any application that is on your computer, or any application that you're running on the web browser, if they are connected to the internet, they are using HTTP. So for example, if you have Microsoft Excel or Microsoft Word, and you save a document, and that document is being saved to the cloud somewhere, Microsoft Word or Microsoft Excel or Google Docs, any of these applications are using HTTP to save your file to some remote server somewhere. So again, in this analogy, your computer is the client, and the computer that is saving your file is the host. Now, in order for HTTP to translate into your file being saved physically on the computer, it must make its way down to the 2nd, 3rd, and 4th layers of the TCP/IP model. Okay, so let's understand this idea by looking at the next slide. Let's say you go to the apple.com website and you want to register your account. You want to buy an iPhone, and the first thing you need to do is register your account. So you have the form. Okay, so first off, let's start here at the application data. Okay, before we get to these, let's start here. You open the registration form. You type in your first name, you type in your last name, your email, phone number, what have you, and then you click on submit. You click on that submit button, which is supposed to take your data and put it on the apple.com server somewhere. The following layer, this is the application layer where we have HTTP. Okay, so here's the model again. HTTP is in the application layer. HTTP will take your first name, your last name, your email, your phone number, and etc., and packet your information, packet your registration credentials. The next layer, the transport layer, this is where TCP/IP exists. Will take care of splitting your registration form into something we call packets. I'll show you a picture of that in a second. Your registration form, your registration details will be split into packets. That's the job of TCP. In simple terms, that's what TCP will do. See, everything on the internet, every connection, every data that is sent or received is done in the form of packets. It looks something like this. Every piece of data, video, image, audio message, tweet, goes into something we call a packet. And a packet has two components: a header and the payload. The header, which is, well, the whole packet is created by TCP. TCP will tell the recipient server, that is the Apple server. And remember, you're filling out your registration form and you want to send your registration details to the Apple server. The header is going to contain the address of the recipient, namely the Apple website, and it will contain the names of all the packets that are supposed to make their way to the Apple server, okay? So let's say, for example, the first packet contains your first name and last name. The second packet contains your profile picture, and the third packet contains your attachment. It doesn't work like that exactly, but I'm just trying to simplify it for you. So the first packet will tell the Apple server that there's another packet coming your way. And the second packet will tell the Apple server there's a third packet coming your way, and so on and so on. And so these packets individually will make their way throughout the internet until they are one by one received by the Apple server, and then they are reassembled into one continuous form of data. TCP takes care of the packaging, okay? The TCP, which is inside the transport layer, takes care of the packaging. And if we go back to the model for a second, okay? So the transport layer takes care of these packets. The internet layer takes care of transferring those packets throughout the internet. So let's say you are somewhere in Stockholm and the Apple server is in the United States. The internet layer, and more specifically the IP component, is going to take care of taking those individual packets and navigating them to the Apple server in the United States. So your packets are going to come individually from Stockholm, and they may be routed to, let's say, another city in Europe, but eventually they will make their way to the United States. That's what IP is going to do. Okay, so let's look at these layers one more time. HTTP is going to tell the Apple server what kind of message is coming through, whether it's a text, whether it's an image, whether it's a video. The TCP, which is within the transport layer, is going to split your information into these things called packets. Then the IP component within the internet layer is going to take care of transferring those individual packets from your location in Stockholm or India, wherever you are, to the Apple server in the United States. Finally, we have the link layer. The link layer is responsible for translating all of these information into ultimately binary data, which translates into ones and zeros in the hardware, like electric signals. So if I take you back to this diagram one more time, here is how that scenario plays out again. This is your registration data. You fill it out, you fill out the registration form, you click send. Then HTTP is going to say, okay, this is the text, this is the image, and let's say this is an attachment. Whatever the attachment may be. Maybe it's your, let's say your receipt. Let's say you want a refund, whatever. So HTTP, which is in the application layer, is going to take care of telling the Apple server what kind of data is coming through. That it's a text, that there's an attachment, and there's a document. The transport layer is then going to split that HTTP request into these things called packets, into these individual pieces of data called packets. And then the IP component within the internet layer is going to take care of transferring those individual packets, making sure they all make their way from your location to the destination. And then finally, the network layer is going to take care of translating that data into electric circuits. Now, what do these header boxes mean here? Well, when you wrote your registration form, in the application layer where we have HTTP. HTTP contains your data, but then there's this header compartment, which is going to describe what your content is about. Text, image, document, what have you. The header is going to describe that. The application data together with the HTTP header will be contained inside transport layer as another package. So let me describe this scenario with an analogy. Let's say someone asks about the OSI model. I will talk about the OSI model in a second. But let's take a step away from the TCP/IP model for a second, and let's think about a real-life example of packaging. Let's say you want to purchase a phone from the Amazon website. Okay, forget about internet communication and everything for a second, but let's think about physically, like shipping. How are they going to get that phone to your destination? You order the phone, and then someone in the Amazon warehouse is going to take that phone and it's going to package it. Or let's say you're buying the phone from Samsung. They put your phone in the package, right? And the package has, for example, a picture of the phone and what's included. It comes with a free cover. It comes with a free pair of earphones, and yeah, and it has and it has one of those labels, those stickers to make sure that this package hasn't been opened. That's the first level. And then Samsung gives your package, your box, your Samsung phone, to the Amazon, which is going to who are going to take that box and ultimately deliver it to you. They will take that box and put it in another box, right? They put it in these gray carton boxes. And then they put a sticker on it that says, this is the customer, this is their location, and they move that box onto, let's say, the logistics company, like FedEx or DHL. They, in turn, will take that box and wrap it some more with instructions about how it should make its way to, the DHL office in, let's say, Stockholm, where you're living. Okay? My point is this. From the point where that phone is at the factory until it gets to your home, that phone is going to be packaged and packaged and packaged and packaged. And with each package, more information is added to each subsequent package. And each information that is attached is going to describe how to unpackage or how to deliver that data. Okay? So you have your phone, it's in a box, then you put that into one of those brown boxes, and then you wrap that some more. So when it comes to the logistics person, to the DHL delivery guy, he's going to look at that piece of paper, that piece of sticker on the box, and it's going to go, oh, I have to deliver this to this house on that street. So they bring that box to you. And then once you receive it, you open that box, and on that box you have the Amazon box, which says this is from Amazon, it's from the Samsung company, and it is for you the customer. Okay? And there is your, let's say, your purchase ID. So if you want to return it, you can take that purchase ID, go to the website, and then fill out the form for returns and refunds. You then open up the Amazon box, and there we have your phone, like the actual Samsung box. And what does that Samsung box have? It also has stickers. It also has information, like, for example, how to open the phone, how to boot up the phone, how to connect your cover. You know what I'm talking about. The same idea applies. That analogy applies here. As your data makes its way down down the layers of the TCP model, more headers will be attached. So this header will describe what is contained in your HTTP request. And then the header in the subsequent layer is going to say how this entire package, including the header or your HTTP, should be packaged, how it should be distributed. Remember, that's where we have TCP/IP. Then the subsequent layer is going to describe how this other entire package, this new package, should be handled throughout the different nodes in the internet. And then finally, we have another header that's going to describe how this entire thing, all of it, should be translated into electric signals in the computer hardware. Okay? Now, I know that's a lot of information to absorb in a short span of time, but if necessary, I will come back and explain this again with another analogy to make sure that you understand this clearly. Okay. By the way, if anyone has any questions, you don't have to wait until the end. You can actually put them in the chat, and I will address them as we go through the content. So the next thing I want to show you now, while we're on the topic of TCP/IP, is this. Something called the OSI model. And I know Ganesh put a question about the OSI model. So chronologically speaking, the TCP model preceded the OSI model, but it is very similar to TCP/IP. So OSI is not necessarily, it's not limited to the internet, but nonetheless, it has very similar layers to that of the TCP/IP. So let me just touch on this very quickly. So for example, if you are someone who wants to learn about computer networking, you will inevitably come across the OSI model. Okay, so you might be confused between what's OSI, what's TCP, why do we have both? You can think of TCP as an abstraction of the OSI, although I said that TCP/IP preceded OSI. So for example, the OSI has 7 layers instead of 4, but you can see here, TCP encompasses the first 3. So application, presentation, session, TCP considers them as ones. And it makes sense. Any application that you know of, Facebook, Twitter, YouTube, they all have a presentation component. So meaning there's a user interface, and there's something called a session, right? You can register, you can log in, you can close the window, open it up again, and you're still logged in. So those 3 components, TCP considers as one. I mean, that's the application. All 3 have to go, have to be contained in the application anyway. So TCP considers the first 3 as one layer. And then we have the data link and the physical link at the very bottom. So the first three translate into one layer in TCP/IP. The 4th and 5th translate into the 2nd and 3rd layers of TCP/IP. So transport is transport in TCP/IP, and network is also network in TCP/IP. Sometimes they call it the network layer in TCP, sometimes they call it the internet layer, but they're both the same. Data link and physical. Data link has to do with the software at the hardware level. Okay, so think about the Ethernet cables, the routers, the modem. Like your router, for example, is mainly hardware, but there are some software components. OSI makes a distinction, but TCP/IP doesn't. Say they're both the same thing. Like they're both, part and parcel of each other. Now, it's not very important for us to know like the OSI in great detail or the TCP/IP in great detail, but it's important for us to know this because we will appreciate the technicalities of HTTP more. But now I want to tell you about how the TCP/IP model processes your connection request from the moment you type a URL in the browser to the point the data makes its way to you. So this is another way of looking at the previous slide, which we had over here. Okay, I'm going to give you another diagram to illustrate the idea of how communication on the internet works. So let's go over to slide number 17. And by the way, all of these slides would be shared with you all after the session. So this video is being recorded and the slides will be shared in our Slack channel. So we will do this diagram and then we will jump into Postman So I can show you how, show you a few examples of, you know, the HTTP communication. Let's go back to that example where you want to visit the Apple website. And let's now take a step backwards and not talk about, you know, registering your account and, you know, registering your account and how the TCP works specifically. Let's now take a step back and take a more broader look at how the browser works, how the browser is going to take your information, send that information, and how it's going to eventually make its way to the Apple server, apple.com server, and how that Apple server will respond and how that response will make it back to you. Okay? So the previous diagram I showed you with the TCP/IP model, those 5 layers, that's one way to understand computer communication. This is another one. When you type in the URL of the apple.com server, so when you type in https www.apple.com, the browser, remember that diagram I showed you with the client and the host? Here, your browser is the client. The client is going to take the URL that you've just typed in the browser and decide how to proceed. So here, if we go into, before I jump into the second step, let me show you this, diagram, this slide, and then I'll come back here. This is the URL scheme. So I'm going to zoom in into this part for a moment. Okay, I'll explain this, then we'll come back to this slide, and I'll tell you about DNS, TCP, and the other ones. And then we'll get into the Postman tutorial. So let's go back to the previous slide. Here is an example of a URL. Of course, we've all seen these, but now let's break down a URL into its subcomponents and talk about how the browser understands a URL, how it you know, makes sense of it. So this is the URL, and these are the components on the row. So we have HTTPS on the side here, www, and of course, you know, the other ones. And let's quickly run through these. Remember that I told you in the application layer. So we have 4 layers: application, transport, network, and the link layer. At the first layer, at the application layer, we have different types of protocols. You have HTTP, which is for web documents. You have FTP, which is for file transfer. You have SMTP for, of course, sending and receiving emails. Or SMTP is for sending, POP3 is for receiving. So the first thing that the browser will look at will be the protocol. The browser wants to know, what are you trying to do? Are you trying to read a document? Are you trying to send an email? Are you trying to send a file? So first, it goes, okay, I see that you have HTTPS here, or HTTP. That means you are trying to talk to a web server. That's number one. Now, we have 2 things we want to look at. The subdomain, that's the www, and the top-level domain XYZ. So the way a DNS will work, I'll tell you what a DNS server is in a second, is it will go from right to left. Okay, so once we've established the application protocol, we then want to find an IP address. By the way, a domain name is only for our convenience, meaning, you know, us people, right? Every application has an IP address associated with it. The problem with the IP addresses is that they're all numerical, which means we can't memorize them. It will be, I mean, we would have trouble with our username and password. Imagine if we also had to remember the IP addresses of every application that we work with. So we have more user-friendly, you know, naming conventions. So instead of using numbers, we use, you know, letters, words to make sense, to remember the name of an application. But computers don't. They need an IP address. They need that number system to facilitate communication. So the way it works is that first, we have this thing called a DNS server. The DNS servers are computers with the sole job of taking a name, like a user-friendly name, and translating that into an IP address. For example, when you type in apple.com, the browser will send the apple.com, the name, to a server, to a DNS server, so we can know its IP address. Once we have the IP address, can we talk to the actual Apple server? So it's a two-step process. Fundamentally, it's a two-step process. First, we need to know the IP address of the website's name. Then we can, once we have the IP address, can we, start talking to the application. This is true for any server, whether it's a web server, it's an email server, file server, it doesn't matter. It's not enough for us to know the name. If you already have the IP address, we can skip the first step. We can skip the step where we have to talk to a DNS server. We can talk to the server directly. But if all you have is a name, like apple.com, google.com, facebook.com, then it's a two-step process. First, you get the IP address, then you can start talking to Facebook, Twitter, Apple, so on. So the way DNS servers work is that there are DNS servers for different top-level domains. So there's a big cluster of DNS servers for .com addresses. For example, the computers on those DNS servers have these big databases of any website that ends with .com, apple.com, google.com, facebook.com, amazon.com. If the browser sees that it's something.com, it's going to send its request to that cluster of computers. Okay? So actually DNS is not one computer, it's a system of computers. And depending on your top level domain, you will be sending it to a particular DNS server. So there are DNS servers for .edu, education. Like all universities have the .edu top level domain. And that means if you want to connect to to some university website, once you type in the URL, the browser is going to send it to the other cluster, to the other set of clusters, instead of going to .com. For example, the Big Number website uses the XYZ top level domain. XYZ is not that popular, so there's a smaller cluster of DNS servers. Nonetheless, there is a DNS server there's a cluster of DNS servers for all kinds of top level domains. .org, .net, .xyz, what else? So many are coming up, .cc, .us, .uk, .ca for Canada, and so on and so on. So first, the browser will establish the top level domain. Which cluster do I need to send this request? In this example, it's XYZ, perfect. So once we send it to XYZ, then we need to know, of course, well, then the browser is going to say, hey, DNS server, there is a website called Big Number within your cluster. Can you pull up the IP address? Can you please pull up the IP address? By the way, the application to which, or the application that I'm requesting is a World Wide Web server. So I'm not here for emails, I'm not here for pictures, I'm not here for documents, I'm here for a web document, okay? So the subdomain is going to help the DNS server more quickly find the IP address of this website, okay? So one more time, first the browser will establish the protocol. It will first know what you're trying to do on the internet. Are you trying to receive a web document? Are you trying to watch a video? Are you trying to send an email? Then once it knows what you're trying to do, it will then send your name, the name of the website, to a DNS server or a cluster of DNS servers. And what cluster it sends this request to will depend on the top level domain. Is it .com? Is it for is it commercial website? Is it .org? Is it like a non-profit organization? Is it .edu? Is it an educational server, and so on? It just makes things more. It just makes the process of giving a name and getting IP address more quick. It makes it much faster. So the browser will then, after we know the protocol, after we know what we're trying to do on the, what the user is trying to do, it will then send this information to the XYZ DNS servers. Then it will say that there's a website called Big Number listed on your computers in your database. Please give me the IP address of its web application. For example, when you register a domain name on GoDaddy or Media Temple, you have the option of choosing different subdomains. You can have www. You can have app.bignumber.com. You can have video.bignumber.com. And what the subdomain corresponds to an application within your, let's say, your set of applications. So, for example, Google has many of these subdomains. There is one for their search engine. There is one for their cloud services. There's one for their photos, the Google Photos. Same thing with YouTube. Like with YouTube, I don't know how many of you have upload videos to YouTube, but there's something called studio.youtube.com. So studio.youtube.com is an application that is separate from the main YouTube application. That's why you have two different subdomains. So every subdomain in the URL corresponds to a different application under the umbrella of one brand name, for example. So yes. And then once we send this information, to the appropriate cluster, we meaning the browser, once the browser sends this information to the appropriate cluster and the cluster finds the IP corresponding to the domain name, the browser will say, okay, here's the IP address that I need to know about. And then, well, it will make its request. It will make its HTTP request. So for example, once we have the IP address, we can say, okay, give me the courses page within the application. Give me the, let's say, the login page within this application, and so on. Okay, so this piece of information is going to help you later on. By the way, the subdomain, the domain name, and the top level domain together, we call that the resource name. Okay, so the resource name is broken into three parts: top level domain, subdomain, and then of course the domain name itself. Like that's like the brand name: Apple, Nike, Adidas, so on. So let's go back to the previous slide. We took a quick detour to understand URL schemes. So here is how. Let's go back one level. Let's go back one step and understand how the connection works. So the browser takes the URL, looks at the scheme, looks at how the URL is structured, and then it knows how to proceed. It knows how to continue with the communication. It then sends its request to the appropriate DNS server. And DNS server, which are these special computers, and their sole job is for telling you this domain name corresponds to this IP address. That's all they do. They take the domain, they take the brand name, and they give you the IP address. Then the DNS server responds to the browser, and the browser knows the IP address of the computer. So let's say in this example, it's apple.com. Now that we have the IP address of the apple.com server, we can proceed with the TCP connection. So let's say you are trying to register that account I told you about. The browser can now take your registration information, your name, your email, your password, your profile picture, attachment, and then start splitting it into those packets. Packet. And then once you have those packets, it will use the, it can proceed with completing the HTTP process. Okay? And it is at step 4 that I want us to now switch to the application. So I can show you an example of HTTP methods. I'm going to show you different HTTP methods. I'm going to show you I'm going to briefly tell you about HTTP status codes. And then, we will revisit these diagrams to complete our understanding of HTTP. So here is that Postman app. If you see the screen, you can skip this. You don't have to sign up. You can skip right to the application. So just click on down here where it says, like below the sign up button, it says here, take me straight to the app and I'll create an account another time. You can do this later. So click on that link and now you should have this interface. You can skip that and you can close this window. I'll show you how this thing works. Eric asked, how does HTTPS differ from HTTP? Where in the process is it checked whether a program, a .html program uses HTTP or HTTPS links or both? And why do HTML programs that use both sometimes fail? Well, to answer your question shortly, HTTPS is a secure secure alternative to HTTP. HTTP is not very secure. HTTPS has a way of encrypting those packets I told you about are encrypted so that certain security loopholes are, dealt with. I don't want to get into like SSL and encryption in this workshop. That could be a topic for another day. But to answer your question shortly, simply, HTTP is a secure way of encrypting data. It is also, and to answer the second part of your question is, why do HTML programs that use both sometimes fail? If your website claims to have an SSL certificate, but that SSL certificate is not valid, then the browser will notify the user by saying this website is not secure. If you have a mix of HTTPS and HTTP links, that can happen. So let's say you have an HTTPS website and then you have hyperlinks in different parts of your website that point to HTTP. That's going to throw off the browser. So what you want to do is make sure that you're either using HTTPS everywhere or using HTTP everywhere if you don't have an SSL certificate. I will also talk about hyperlinking after we do this short tutorial. Let's look at a simple example of this application. I'm going to close the sidebar here. Let's close that. And I just want to get rid of the sidebar. By the way, if you want to collapse the sidebar, you can click on this icon here next to the new button, open and collapse it. The first thing I want to bring your attention to is, of course, the URL bar. And this drop-down list here to the left. If I click on it, you will see that there is a list of, these are HTTP methods that you can choose from. There's get, post, put, patch, delete. Now the most popular ones are the first 5, but even the last 3 and the first 5 are used rarely. In fact, you can accomplish all kinds of web application processes with the first 2. I will describe these 2, but just know that what you're looking at right now, these are called HTTP methods, and they are uppercase for a reason. So it's convention that when you refer to an HTTP method, you use all uppercase letters. So first, let's do a simple get HTTP request. I will explain to you its parts, and then I will show you another example with post. Knowing how this tool works, knowing how HTTP methods work is very important for 2 reasons. If you're someone who is considering, learning how to code, learning to become a web developer, you will you will need to know about this tool. Okay, this is a professional tool. This is not professionals use this all the time for developing APIs, for testing their applications. And even if you don't want to be a web developer, you're just experimenting, this will help you learn a lot more about how applications work in general. So if you are considering getting into web development or building, applications in general, it could be desktop applications, it could be mobile applications. Every application now is connected to the internet, So if you want to get involved, you need to know how, you need to know the basics of computer communication at the very least. You need to know HTTP at the very least, which means you need to work with an application like this. Okay, with that out of the way, let's look at a simple example. So from the drop-down list, don't choose anything, go with get. That's the default. And here we can here we will type in some URL. Since I've been talking about apple.com, I'm going to go ahead and type in the apple.com URL. So first we will type in the protocol. Let me zoom in so you can see more clearly. So the protocol is HTTPS. Okay, so here we are going to tell Postman that, we are going to get a web document. By the way, what we're doing here, the way we're setting up this tool is the same way the browser works. Okay? So first we type in the protocol, then we have the subdomain, www. Keep us typing. Okay, and then the name of the website, which is Apple, followed by the top level domain, .com. And we don't want to visit a particular page, we just want to see the main page. Now, but usually that's index, okay? But even you can leave that out. So we don't have to specify index. So we can just go with, we could go with this. Then we can just go ahead and click on send. Okay, when we click on send, we are going to see what's missing. HTML. Oh, okay. Okay, so if you see this, you will see a lot of line breaks. I think it's because the way the Apple website is coded, there was like 36 line breaks in the HTML. Not sure why that is, but nonetheless, if you scroll down in the body section, you should see the HTML of the Apple website. I'm going to explain HTML anyway, but let me show you something. So let's go to the apple.com website, and I want to show you something. So even if you don't know HTML, just look at this part, the first line number 37 and 38. So we have this thing called doc type HTML, and then this thing HTML, XML, NS, something, something, something. Okay? Just look at the first two lines here. Don't worry if you don't know what HTML means now, just look at this. And then we're going to come over here to the browser. And I'm going to inspect the code of this website. That's the apple.com landing page. And I'm going to use a tool in Chrome called the inspection tool. So what you want to do is you want to right click anywhere on the screen and then choose inspect from the list. So just click on anywhere, then right click, inspect, and then what you should then see is this panel open up. This panel opens up. And you want to make sure you have elements selected. Now, we won't get into this right now, but I just want to show you something very quickly. If I scroll all the way to the top, there you can see doc type HTML and the HTML, XML, and that thing. So the same thing you see here, we have in Postman. So Postman can do what the browser does. Let me close it very quickly, and I will come back to HTML later on. HTML is about how the website the UI of the website is structured. So for example, how we have this nav bar at the very top, how we have this text, this big text, this advertisement. We have these two links, then we have this picture. And then if I scroll down some more, we have this, advertisement, this big iPhone 11 text, the links. So the way you want to structure the layout of your website, use HTML for that. But my point is this: if I bring back the Postman application here, Postman won't show you, Postman won't show you the visuals, but it will show you the HTML code corresponding to, or the HTML of the apple.com website. So when you type in the URL, and you click on send, and you see the following HTML, you have completed an HTTP request. You have gone through the TCP portal, the TCP IP layers that I told you about. All of those. So converting the DNS name, or rather converting the domain name to an IP address, and then creating packets, and then routing those packets to the server in Apple server in the United States, and then of course converting the data into binary. So when I switch to my browser, and you can see the apple.com website, that's because at the fourth layer, where we have the link layer, we have converted the binaries that came from the apple.com server, and we converted that to electric signals. So the screen on my computer has black at the top and white at the bottom because of how the data was transmitted. But let's not get into data representation for now, and let's come back to the Postman application. Okay, my point is the Postman application will allow you to experiment, HTTP requests and understand how the TCP IP model works. So you can scroll all the way to the bottom and you will see the entire HTML of the apple.com website. Now let me show you something else in a GET request, and then I'll show you POST. But before I do that, just understand something. The GET request, the GET HTTP method, is only used when you want to receive something from the host. So one more time, let's go back to the slides for a second. So remember the first slide I showed you? This one. Here, our Postman is the client, and apple.com, which we have typed in here, is the host. If all you want is to receive something from the host, like a web page, or a video from YouTube, or a picture from Facebook, or an email from Gmail, then you would use GET. Email is different. But if you want a picture, a video, or a web page, you would use a GET request. You would only use a POST HTTP request when you are trying to, post something. You're trying to send something. Let's say you are trying to change your profile picture. Okay, then you would switch to a POST request, which has a different way of being packeted. And if you were trying to upload your picture, you would use the POST data, and that will be packeted accordingly. I'll come back to POST later, but let's go back to GET. I want to show you something. Now, sometimes you may want a web page, but you also want something specific on that web page. So let's say this. Let's go to the Amazon.com website. So let's open this together. Here we go, Amazon. Let me get Postman out of the way for a second. Here. And let me zoom out so you can see the URL. So, okay. So let's type in the name of a product. Let's type in iPhone. Okay. By the way, notice the URL. So let me open. So when you type in Amazon.com, that's all you have. Nothing comes after it, and then you have the landing page. But then watch what happens when I type in iPhone in the search bar and then I click on enter. Do you see this? And I'm going to bring this over to Postman so you can see it more clearly. Okay, great. So I'm going to copy this and bring it back to Postman. So let's paste that in here. And I'm going to click on send parameters. There we go. Let me get rid of this for a second. So here we have the URL. And we already know what this is. We have the protocol, https:////, that's the protocol, top level domain, subdomain, and of course, the domain name, the brand name. And then we have this thing. Once we typed in iPhone and we clicked on search, this thing appeared. This, the S in here, the S, zoom in. The S is usually, if I can get rid of this part, anything that comes after / corresponds to a page, or it can even be it can be a document. But in this example, the S here is supposed to be search. But I guess Amazon uses S for short. But what they're trying to say is, when we clicked on the iPhone, when we typed in iPhone in the URL and then we clicked on send, we were taken to a different page, the search page, where you have different page search results. Okay, that's over here. Okay, clearly this is the search results page where we have different kinds of iPhones. But then what you see here after the letter S is what we call the parameters. You see the question mark here? That is an indication that you're looking at parameters. So this is how you can filter your request, or you can refine your request. Here, if I were to take this out, let me show you what happens. Let's go back to the browser for a second, and I'm going to take out everything that comes after the question mark, and I'm just going to leave an S over there and see what happens. So they take us back to the main page where it's supposed to be searched. I'll show another example with Google to explain, to make my point clear. So let's go to google.com. Okay, same thing. We have, the same URL scheme I showed you before. Protocol, top level domain, sub-level domain, and then Google. Now I'm going to search something. I'm going to search for iPhone. And if you look up here, let me bring this URL here in Postman. Let's look at all of this stuff. That's a lot of parameter. Let's click on send. And let's focus on everything that comes after the question mark. By the way, if you were ever curious about analytics, if you were curious how YouTube knows what your next search should be about, how when you go to Amazon, they always give you these recommended items, it has to do with what you're seeing here, the parameters. So the structure of the parameter, so let's first talk about the structure of a parameter. Here's how you know that you're looking at a parameter. If you ever see a question mark in the URL, anything that comes after that question mark is the parameter. But then you can have multiple parameters in the URL. How do you know that? When you see the ampersand, the and sign. So here's how parameters work. The first parameter can be, let's say, some kind of filter. For example, you're searching for a product, so iPhone. But then you have more parameters. So let's say you want to sort by price. So what you want to do is The first parameter always begins with a question mark. The second parameter begins with an ampersand. The second and every subsequent parameter has an ampersand. So question mark and then ampersand, 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 and so on and so on. So you're looking for an iPhone and you want to sort by price. But you also want to sort by, let's say, screen size. So let's say 6. And you also want to sort by availability. So you don't want to see iPhones that are out of stock. So you can have another parameter, availability, or we can say stock equals yes. Okay? So the first parameter begins with a question mark, then your criteria followed by its value. And then again, the criteria followed by its value. Again, the criteria followed by its value, and then on and on and on and on and on. Okay? So just remember this. Whenever you see a question mark, you're looking parameter. And whenever you see an ampersand, those are the subsequent parameters. So now that we know this, let's go ahead and look at the parameters of Google. Let's see how Google stores information about you. You can do this example, by the way, on your own. Click on the parameters button. And when you do that, Postman is automatically going to break down the URL and create a list of all of the parameters from the URL. Some of this information is encrypted, so we can't make sense of it. And of course, they do that purposely. One of them is because, well, they don't want you to know what that is, but also because encryption can help reduce the size of the data. But some of this we can recognize, namely Q and OQ. I want to bring your attention to these two parameters. Q stands for query, and OQ, can anyone guess what OQ stands for? Any guesses? Let's go back to the browser for a second. And let's find Q here. Where is Q? So we have SXRF. I don't know what that is, but then let's see if we can find the next ampersand. There we go. And then if we go further, we have EI. We don't know what that is, but let's see if we can find Q. Q. Oh, there we go. There's Q. Q, iPhone. Okay. So here's what OQ is. Now that I have iPhone, I'm going to search for iPhone 11. Okay, and I'm going to copy this URL and bring it back to Postman. So someone said optimized query. No, it's not optimized query, but nice try. Let's paste that in and maybe you can guess again. Okay, so I've now just pasted the URL. Look at Q and look at OQ. What do you think OQ is now? Any guesses? No? Oh, you're almost there. You're almost there. So OQ means original query. Original query. Our original query was what? iPhone. And then we narrowed down our search and we searched for iPhone 11. The plus, by the way, in the URL, when you see a plus, that's just a placeholder for space. You can't have spaces in the URL. It has to either be, you have to use a dash or a plus, or there's something called URL encryption. My point is you cannot have a space or a line break in a URL. There has to be something. So Google knows what our original query was and what our subsequent query was. Now we don't see it here, but before, when you would do a Google search, you could see information about your browser, your location, and even your operating system in the parameters. So the Google search engine would know what you were searching for initially, then how you and then what you search for subsequently, what platform you are doing the search from. Is it your phone? Is it your laptop? Which operating system you're making the search query from? Is it a Windows? Is it a Macintosh? Is it an Android? And then it knows what computer you are doing the search. Is it an HP laptop? Is it a MacBook? Is it a Lenovo? And so on. So they know all of this information about you by that one search. Through that one search, they can learn so much about you. The same holds true for Facebook and Twitter and YouTube. They all know how and what you are searching for. And that, of course, allows them to enhance their product. So for example, if they notice that more people are using their phones to search, which is now the case, they will invest more into their mobile platform. If they notice that people are using the web version, so for example, they will take their phone and they type in their web address as opposed to going to the App Store, well, then they will figure out, you know what, not many people are using our native application. Maybe we should stop putting so much time and money into our mobile application and focus on the website, which, by the way, is the case. Unless you're a big company like YouTube or Twitter or Facebook, you know, who have hundreds of millions to even billions of users, no one's going to download your application from the App Store. So now that's a discussion for another day. But if you want to get into app development, if you want to build an application, either because you want to switch careers or you want to build a product of your own, start with web development before you get into mobile development. But anyway, I want to come back to the GET request. So unfortunately, they've been encrypting more information in their URL, but nonetheless, we were able to make sense of some of the information that we see here. So again, here is the original URL, and then followed by the page, and then we have the parameters. And you can do this with any other website that you want to experiment with. They will all follow this convention. If you want to refine something, you will have question mark for the first parameter, and then ampersand for subsequent parameters. Now, I also want to show you something else. This website is called JSON Placeholder. Here's the website. If you want, again, this is for those who want to get into web development. If you want to get into web development, I want you to be familiar with this website. This website allows you to make test HTTP requests specifically for a data format called JSON. So I've talked about web documents, I've talked about video documents, emails, but there is a special type of data format called JSON. That's short for JavaScript Object Notation. This is an increasingly popular data format on the web. It's popular for a number of reasons, mainly because of the popularity of a program language called JavaScript, but also because of the ease of the data format. It's just very easy to read it. It's very easy to make changes to it. Well, let me show you a very quick example. I'm going to copy this JSON placeholder URL. Actually, let's copy this one over here. And bring back the Postman application. So we go here. And let's replace this entire thing with this URL. Then we're going to click on send. Now you can see when I clicked on send, now we are not seeing HTML. We don't have doc type and HTML. We have this. We have this thing with the open curly bracket and the closed curly bracket. It's just so much more, it's just so much more smaller data. This entire thing we call an object. Okay. This is called the curly bracket. This is called, that's the opening curly bracket. That's the closing curly bracket. And then here, what you see on the left, or rather in the first item in this object, we have three parts. We have the key. That's what we call the key between the quotation marks. And then we have a colon, and then we have the 1. That's the value. So key, value, key, value, and then of course key value. Increasingly, more applications, more companies are adopting this data format for sending and receiving data, and even storing information in the database in this format. So when you register, if you're a user and you register your account on some application, your information will be stored in this format. So it could be something like first name, your first name, and then last name, your last name, your email, and then your address. There are, of course, different data formats in which, there are different data formats that a database can use to store information. There's something called SQL. There's XML. You can even store information in text files. It's not ideal, but you can do it. But JSON is used because of its incredible flexibility. Maybe that's something you should read about on your own later on, and maybe we can have a workshop on that topic. But I just wanted to show you that when you can make different kinds of HTTP requests. More specifically, you can make different types of HTTP GET requests to a server. So not only can you request an HTML document, you can also request for specific types of, or rather different types of data formats. Now here's what I want to show you next. I want to show you the structure of an HTTP request. So what I want you to do is this. Here, you should be able to see a link that says code. Click on this, this link over here, and then a window should pop open. Okay, and what you're looking at is the structure of an HTTP request. Okay, this goes back to the application layer that I told you about in the first part of the presentation. Here is exactly what's being sent by the browser to the host server. So here in our example here, Postman is the client. Postman is the one that requests something. Let's actually use apple.com. So let me switch to apple.com very quickly. Let's open a new tab here. HTTPS to apple.com. Click on send, and let's look at the code. So Postman here is the client, and apple.com is the host. And you can see here, we even have the name. We have this key here, host, apple.com. And every other information that goes along with our GET request, like our parameters, our authentication tokens, if you want to log in a user, or if you want to confirm to the apple.com server that you're a logged in user, all of that information will be put into the HTTP request. So it starts with the HTTP method. It tells you whether it's a GET request or a POST request or a PUT request and so on. And then it tells the server which HTTP version it's using. Now, originally we had HTTP 1.1, but we are moving towards the adoption of HTTP 2 and HTTP 3 in the future. But this is the format of an HTTP request. What kind of method? Its version. Who is the host? Whether there are cache, whether we want to cache something. So here, for example, if you don't want the server to cache your information, you can include that in here. And then information about cookies, parameters, sessions, authentication. All of them go down all of them will go into this snippet, and they follow the same format. You have the key, colon, followed by the value. Now, if you were sending a picture or a video, like I said, you would be using POST instead of GET. And so if we go back to the slides for a second, that snippet I showed you, the HTTP snippet that I showed you, that is this part. It's this layer. Okay? Any information you have about authentication, let's say you get requests, sometimes when we can get request, you need to be logged in to see a page. For example, if you want to go to, let's say, apple.com/profile, access the profile page unless Apple knows who you are to begin with. How is Apple going to know whose profile to show? Is it my profile? Is it your profile? It needs to know somehow who this person is that's trying to access the /profile page. Well, that's the token. The token, if you have something, the token, by the way, it's a piece of code that contains, let's say, your user ID, your email address, anything that, you know, indicates who you are. That will be put in the header section. Okay? Your GET request will be put in the application layer. Any authentication information, if available and necessary, will go into the header section. Then all of that HTTP request will then be given to TCP/IP, TCP in the transport layer. TCP will take that HTTP snippet I told you about, wrap it, and then package it, or rather split it into different packets. That's the slide over here on slide 13. Your entire HTTP request will be split into these packets where you have a header and the payload. And then once that's done, once that splitting is done, we will move on to the internet layer. So now we have those individual packets. You have 10 packets, 20 packets, however many packets they are. All those packets will then be given to will be moved on to the internet layer, where the IP part of TCP will start delivering them. And those packets will make their way from, let's say you're in Beijing. It will go from Beijing, and it will go to Shanghai, and then from Shanghai, it will make its way to Central Europe, and then eventually will make its way to the United States. Okay, so the internet layer is going to take care of delivering those packages. And of course, finally, we have the network layer, where the data is translated into, you know, ultimately electric signals. And so now it's important for us to also know about the HTTP system more generally. By the way, HTTP stands for HyperText Transfer Protocol. HyperText Transfer Protocol. So in order for us to understand HTTP more generally, it's also important for us to know three components: the concept of hypertext, the markup language, and we have different types of markup languages, but here we're talking about the hypertext markup language, or as it's known by its acronym, HTML. And of course, the internet in which, you know, HTTP functions. Hypertext, the concept of the hypertext, and the markup language were both designed by someone you may have heard, someone whose name you've definitely heard before, Tim Berners-Lee. He's known as one of the fathers of the internet. Hypertext refers to this concept of documents that are linked to each other by, well, we know them as links, but they're called hypertext links. So for example, you have a page, and then there's somewhere in the page, somewhere in the text, you see a word or a few words, and then there's an underline underneath that word, indicating that something you can interact with, it's something you can click, and you click on that, and that takes you to a different page. That's the hypertext. The hypertext is a system that allows you to go from one document to another document to another document in the thing we call internet. Okay? If you're able to put up these documents in different servers all over the world, and you're able to link them together using hypertext, you have given birth to the internet. Okay? The markup language is how you present those documents. Okay? So you know how you want to link these documents, and you have a method to request documents and to send requests. but you also want to be able to see those documents. You want to be able to, like a visual representation of that thing you're requesting. If you want to request an XML file, if you want to see something with tables, columns, and rows, if you want to see product specifications for a phone, there needs to be something that allows you to visualize it. We have different formats for visualization. We have PDFs. We have, which is, you know, for books, for brochures. We have TXT for plain text. We also have not XML. XML is data format. But my point is this: we need something that allows us to visualize a document on the internet. Something needs to contain our text, our pictures, our videos. And that's where the markup language comes in. Both the concept of the hypertext and the syntax of the markup language were, you know, created by Tim Berners-Lee. So the markup language is what we looked at earlier with Postman, when we looked at the HTML syntax. So let's open this here. And I'm going to pull up that tool again. And I'm going to show you something. Again, if you want to use this tool yourself, you want to do a right click and click on Inspect, which will pull up the console panel. So a lot of this, you don't need to know everything in here, but I just want you to have an idea. The landing page of the Apple website, where, you know, they are showing you the products they have, their main flagship product, and the different kinds of the alternatives they have, the options they have, their computer options, and pictures, and more links, more hypertext links that will take you to their different documents. So here's an example of HTML. I'm going to use this tool to show you a portion of this HTML. Click on this, hover my mouse over, for example, here, the buy button. And you can see here that this portion of the HTML, this is the hypertext markup language I was talking about. This portion of the hypertext markup language, let me actually copy it and bring it on the side so you can see it on its own. I'm going to paste that in here. And I'm going to get rid of some of these properties. So this is the basic structure of an HTML element. Now this is a hypertext link. This snippet of code that you're looking at, this makes it possible for you to link from one page to the next. It has three parts. There are mainly three parts. There is the opening tag, and there's the closing tag. So everything that goes between here, between the opening and the closing tag, is going to be the text of that hypertext link. Okay, so here they have the word buy. I bring it back. And then when you click on this hypertext, which is now, so this code corresponds to this link over here, this hypertext link. When you click on that, it will make a GET request. It will make an HTTP GET request to this URL. Now, by the way, you won't see the protocol, the top domain, the subdomain, and the domain name, because it is relative. It is implied. So when you see something like this, what they're really saying is this: HTTPS. So whatever you see in the URL, if I close this for a second, whatever you see here, if you don't see it in the link, so if it's like / and then followed by more text, if you don't see the HTTPS here, that means it is relative. It is relative to what you see here. So this, what you see over here, implies this URL. Okay? But what I'm telling you is this anchor tag allows you to go from one page within the apple.com server to the next. Now, this particular element is only for linking. It is only for going from one hypertext document to another hypertext document to another hypertext document. But there are other hypertext markup language code for different purposes. So for example, there is something called the image tag. This is another example of a markup language, or another example of a snippet within the HTML, the hypertext markup language. It goes something like this. This is going to tell the browser, hey, this document contains an image. This document that the user who requested contains an image, and this is the source. And that could be something like, let me actually show you one from a website called Unsplash. This is free stock photos if you ever need them. Yeah, this URL is actually a great example. So let me bring Postman for a second. You notice how the browser opens this image and you have a black background so you can focus on the photo? That's because the browser was able to determine what you were trying to see. So here's the URL. Okay. We have the protocol, which tells the user that we're trying to access a type of document. But then, if you notice here, at the subdomain, we don't have www, we have images. So the browser looks at this and goes, okay, so you want me to go to the .com DNS cluster. Then there was a website or a brand called Unsplash. I'm going to find the IP address. But within the Unsplash umbrella, within that brand name, you want me to access the images server, not the web document server, not the video server, the images server. That's why we have images here in the subdomain. And then, of course, this entire path corresponds to, now you notice the question mark here? Ignore that for a moment. This path, corresponds to the ID of this photo. And then, of course, these parameters will tell you, for example, what its width should be, what its height should be, what kind of fit do you want. By the way, on Unsplash, you can have like landscape mode, you can have portrait mode. And the other parameters that you see here, if I click on it, these are probably for, its encryption data is probably for their own analytics purposes. Okay? But this is another example. And of course, when you click on send, the way Postman responds is just like how the web browser responds. It gives you the photo. You don't see HTML. You don't see JSON. You don't see plain text. You see a photo. Now, this is just like how the browser responds. Now, the Google Chrome browser likes to give you a better user experience. So what they do is they put the image in the center and they turn everything in the background into black. So all you can see is the image. But Postman is going to show you exactly what the images application of the Unsplash umbrella of applications is going to give you. Okay, we have a few more minutes. Let me just quickly talk about HTTP methods. This is important. I am going to show you a table of HTTP methods very quickly. Sorry, I meant to say HTTP status codes. This image over here. Now, if you notice in Postman, when we sent a HTTP GET request to this URL, we had this thing where it says status 200 OK. This is the HTTP status code for this particular request. Now, what does 200 mean? It means that it was successful. So there are 5 tiers in HTTP status codes. And the numbers correspond to what was the status of that request. Was it successful? Was there something wrong with that request? Is the server not available? So let me quickly give you an example of that. If you type in a URL and it takes you to a different location, you would see something that begins with 3. So like 301, 302, 303, for example. If it starts with a 3, that means you're being redirected from one server to the next server. So that destination that you're trying to visit, that's not your final destination. You're being pushed somewhere else. You know, I think everyone is familiar with the 404 client error. You know, like many websites have funny looking 404 pages like you're lost, click here to go back to homepage or something like that. Client error means that the URL that you're requesting is incorrect. That means you have made a mistake in your request. You mistyped the address, or you're looking for something that you cannot access, or you're not allowed to see that page unless you're logged in, for example. In the event the server does not respond because the server is down, that means well, you know, the issue is not from you, it's from the server. So for example, you may send a request to twitter.com. Sometimes, you know, the servers are down and they don't respond. If you were to inspect the status code on Postman or even the browser, you would see something that begins with a 5. So this is very quickly an example of an HTTP status code. So you can see it both in Postman and you can also see it in the inspection panel. So let me show you that very quickly. I can open up the inspection panel in Google Chrome and you go to network. Let me pull this up so you can see it more clearly. I am going to, now you don't see anything here, but if I refresh the page, you can see here that you made one request. You made a request to this URL, and if you move your mouse over it, it will tell you that you know, this is the URL, the full URL of the request, and it was a 304 status code. You were redirected. You were redirected to another page, and of course it says what kind of document it was, followed by its size, and how long it took for that page to load. Now let me show you the Google website again. If you look at the Google website, the main page, it's super simple. There is the logo and there's a search bar. But then if we look at the network panel, so right click, inspect, network, I'm gonna refresh this page, okay? Same simple design website. Refresh the page and you will see a lot more network requests. I'm gonna refresh this page. And let's see what we have here. Look at that. There are so many requests. So your one request, your one simple HTTP GET request to see google.com translated into, I don't know how many, 33 requests. So as soon as you land it on the Google page, Google in turn, the Google application made 33 different requests. Let's see why that is. If we look up here, so we have some that are 200 status code, these were successful. The first one, of course, is the Google landing page. Then you have a number of images. Whether that makes sense, you have the Google logo, you have the user avatar, you have this microphone picture, you have this search icon. So it makes sense for these PNG icons to exist. But then we scroll down some more, and then we see some requests have been blocked. I guess these could be like advertisements that can be blocked by, if you have AdBlock installed, those requests would be blocked by AdBlock. But that's not everything is obvious. So for example, we have 2 scripts. So Google in turn downloaded these 2 scripts. Now they could be for analytics. It's not obvious what their purpose is just by looking at the name. As you can see, the name, even the name is encrypted, the URL is encrypted. But if you want to learn, now I'm not going to get into the 33 requests of the Google server, but if you want to learn more about HTTP on your own, these are the 2 tools you should be familiar with. Okay, even if you're a pro web developer, these 2 tools you should be familiar with. One of them is the browser console, which we're looking at right now, and the other one is Postman. Let me quickly, I know we are there, let me quickly talk about HTTPS, and then we can wrap up the session. HTTPS makes it so that TCP, when it is packaging your requests, encrypts those packets, the data within those packets, in such a way that something we call eavesdropping and middleman attack is impossible. So simply to explain simply, here's an example. Here's the origin of the HTTP request. Here's the destination of the HTTP request. This is not going to be, if you can think about like flying, sometimes you can take a direct flight from your location to destination, but some cases you have to have a layover. An HTTP packet has many layovers. It has to go through many different nodes before it reaches the destination. At some point between this journey, someone can listen on to your data, or they can read your data. This is called eavesdropping. Another one is called the middleman attack, and that's when they prevent your data from reaching its destination. You can think about like ISPs and in some places where, websites are blocked from being accessed. These are examples of that. But HTTPS is specifically for encrypting your data so that it safely makes its way from the location to the destination. So think about payment gateways. If you want to purchase something, you always want to make sure that it's an HTTPS website. And here, if you focus on my browser, when this Google website that we're looking at is an HTTP, is secured by SSL certificate. And if you click on the lock icon, it will show you information about the certificate. So here it tells you that it's valid. If you click on that, it will give you the information about the certificate, when it will expire, who it was issued by, and more details about that. But to answer your question simply, HTTPS is about secure transmission of data using TCP and IP. Okay, everyone? So I hope you found this session useful. We will have this session again sometime in October, hopefully. Now, this video is being recorded, so it will be shared on our YouTube page. The slides will be shared on our Slack channel. So if you haven't joined our Slack channel, you can please do now. I'm going to type in the URL of our Slack channel here in the chat. So it's HTTPS. So it's secure. Big number.slack.com. So you'll be able to find the slides over there. And of course, if you have any questions about this session, you want to continue this discussion after we're done, we can continue the discussion over there. And with that, I want to thank you all for joining us in this session. So I hope you enjoy your day, your afternoon, your evening, wherever you are joining us from. And I hope to see you all in the next workshop. Thank you, everybody, and I'll see you later. Bye-bye.